always change the recording later on. Okay. Is that picking up? You'll just put it here. Oh, fudge. Okay.
Yeah, I can hear something, but it's pretty quiet on the stream.
Interesting. Well, I mean, is my voice quiet? Or
Yeah,
what's...
your voice is fine.
Okay.
I feel like it's just like maybe like half as loud through YouTube than it is through Discord.
Okay. I mean, if you can hear it on the recording, it's fine. This is interesting. I guess the OBS is probably not liking. Okay, it's actually pretty high up, so I don't think that's the issue. I think what we might end up doing is, I feel like the stream is gonna be gonna look very interesting because it's like this part is recorded. Anyways. So far, 2 people. Maybe I should start, maybe I should ping everyone in the Discord.
Yeah, you should.
I feel like I'm always pinging too much.
Alright, I'll ping you.
Sure, thanks.
Is that an announcement? Notify what? CTF? Or
CTF? Note of CTF. Just that. Okay. Nice. Okay, well, let's see if anyone has joined. Well, 2 people, still 2 people.
I think that's one of them is me. Oh wait, it's not me, never mind. Closed it. Why do people watch on YouTube instead of coming in Discord?
Yeah. Also because it's probably spring break, so people are probably exams. But I will wait 5 minutes and I'll just start with or without people.
Okay.
So let's use this time to burn some time. Or is it kill? How do we kill time? Do we burn at the stake, or do we what do we do with time?
What do you mean?
Gotta kill 5 minutes of time, because you know that time is not valuable any. Or that 5 minutes is not like just extraneous time.
Search for all commands. I'm playing with the immunity debugger right now.
Ooh. Sounds fun.
Yeah, you already know. I'm learning that rev.
Yeah. Oh, I noticed one person that's not here. Paradox isn't here.
He hasn't shown up. He hasn't shown up for workshops. Or he hasn't been showing up for workshops.
Well, he's going to... I probably think we should cut off this part of the recording. But, well, you... Probably the recording you just hear just me talking to myself. But I don't want to stop the recording because then that might mess up the stream.
We're here. What do you mean? We're all here.
Oh, yo, Jerry.
No. I guess everyone's just in a spring break mood.
Dude, aren't we all?
Study time.
Let's see. 3 more minutes.
I actually do have to spend most of the spring break studying. Geez, class is kicking my ass.
Masses.
Oh yeah.
Ooh, we got one more person. A little short.
What time is CTF tomorrow for UT?
Well, it's already started.
Oh, what?
It's
I
like-
start tomorrow. 6 p.m. Okay.
But wait, let me do one thing. Let me.
Register. Event. Oh, CTF time.
Fudge. Well, I'll make the announcements ad hoc. Okay. But yeah. Let's see. Okay, we will start in about 2 minutes. I guess at this point, I'll start with some ad hoc announcements. Well, first of all, number one, we have UTCTF is going on this week. We right now we have CSG created a team that you can join, and other announcements. I believe. I think. Wait. I don't remember what the other announcement was. But yeah, I think the big one is right now we are playing UTCTF. This I believe is like this weekend, probably about 48 hours, if I remember correctly.
Yeah. It is 2 days.
And
12.
yeah, it has already started 2 hours. It looks like already a lot of people have been playing. So.
Wow, they really decreased points for all the solves, man. That's sad. So right now, this question only have 5 points left.
Huh?
Yeah, not worth doing this. It's like the beginner challenge. They have like a sanity check. It's called sanity check.
Oh yeah,
And
yeah.
now it has like 150 solves, and so basically the challenge you can only get maximum of 5 points now.
Well, I mean, everyone gets 5 points. That's dynamic weighting. So, but look at the score. Everyone is like at 20,000, or like the top leaders.
Let's see. Scoreboard. Wow.
So, yeah. But, yeah, we will be playing that this week. Yeah, the other announcement was we won't have a workshop next week because it's spring break. We will have one this week still, and then the next time we will meet is in 2 weeks.
Yep.
Okay. I believe that's right now. It is time. I believe the stream has already started. And can someone confirm that?
Check it.
Okay.
Yep.
Okay, yeah. Cool. So today I will be talking about pwning, and the tagline is "When binaries go horribly wrong." Okay, so the art of pwning. So basically, when you're talking about pwning, you're always talking about whether we are following rules or not. So then, question: what are some implicit rules we follow as like good members of society. How are they enforced? Are they enforced? How are they, if they are, or what happens if we break them? Obviously there are enforcement like police and like law and court and all that stuff that you get yourself into if you try to break the rules. So basically programs also have rules that some programmers set, and oftentimes are they enforced? What happens if a malicious user tries to break these rules? If you design your program correctly, these rules will basically be these kind of rules or ways that you can interact with the program are not going to be bypassable. So then the question is, can we bypass these? So then if are we able to find something like this, you would call this like a vulnerability. So then pwning, the art of pwning is asking, what can we do? What can we access versus what the program should let us do? And then the question we want to find is, can we do something unintended? So never trust user data. And that's a big thing, that as programmers you never want to trust the data that any user can input. And as a hacker, or like if you're doing CTF or try to break programs, you're always trying to think, what input do I have and can I use that to my advantage? So when inputs are trusted. So I believe I showed this program about a few weeks ago. So I'm just going to briefly go through this. So, horrible things can happen. Like, look at this code. And I have the PowerPoint is in announcements. So if you want to access it, you can. I also have the link right here, which has the code. So we look at this program. It's like a bank. You can withdraw cash, and then you have how much, and you can give amount that you want to withdraw. And otherwise, if you're able to withdraw it, it will decrement it from your amount, and then you basically want to have your bank be like $1 million. But you can see that in the bank, you basically don't want to be creating money out of thin air. And that's kind of an implicit rule of this program. But then, is there a way to break it? And we mentioned a few weeks ago, we can actually break it. So how is it checked? So you can see this check right here. It only checks whether if your value is greater than the amount that you have in your bank. But then what happens when you enter a negative amount? And then I can show that here. So if we run it, I have $1,000. How much do I want to withdraw? Let's say if I input like some large negative number, I have withdrawn the amount of money. Notice I didn't check that, and then it's basically now I have that much amount of money in the bank. So yeah, it's kind of the idea. So then here we have the behavior. How do we exploit to get $1 million? And we can see here negative numbers are not checked. So then that's like here we have input that the user can put in. You should always sanitize data and check to make sure that the user isn't entering some weird values. So now the next kind of premise when you're looking at pwning, next cornerstone I would say, is when you're looking at code versus data. So here is a program that obviously no one would ever write, but then you see those programs that have like random evals everywhere. Why would you never use evals? Well, let's look at this program. So we have like a variable right here, and basically in the program you shouldn't be able to have access to that to read this password. So then the question is, you have this input, you get two inputs, and then it evaluates the sum of these two numbers. So it concatenates a plus here and then puts the two numbers here. But what happens? But see here, what we have here is we have some data that's controlled by the user, and then you treat it as like code. So now the question is, can we leak this variable somehow? And then here, once again, I have a number. So I can input two numbers. So obviously, if I do 3 and let's say 5, it'll give me the value is 8. But what happens when I try to enter a string? So let's do string number 3 and let's say another number 10. Oh, I get an error. So I said can only concatenate string, not integer to string. So it turns out this seems like it's evaluating something. So what happens if instead I do this, give it a string number 3 and a string number 3. It becomes 33 because you're concatenating these two strings together. So what happens if I do this instead? So and then put 3 here. Oh, wait a minute. Doesn't that look like the password? And as you can see here, we leaked the password just by like inputting like code here. And basically, you have this concept of you don't want to have code. You don't want data to be treated like code. You want to keep them separate, because if you treat data as code, sometimes it becomes meaningless, and worst case, you could actually hijack the program to make it run something else. So I think that is a YouTube video, I believe is from Live Overflow, that you can look at in your spare in some other time. Okay, and then now we're going to look into C, because this is where pwning gets really interesting. So a brief recap or review of like some C stuff. So we look at a string. What is a string? In C, strings are basically represented as a sequence of bytes. And what's a byte? A byte is just basically a number from like 0 to 255. And so if you think about it, strings can be each like letter would basically be like a number, and that number converts into each number will map to a unique character. So another way to think about strings is just like an array of numbers, where each number in the array maps to a character. So now, having that in mind, how do you know how long a string is if you are a program? So some languages you have like special markers that mark the end of a string, and others you just have like a length field that tells you how long the string is. So if you're looking at like maybe Java or JavaScript or like any other high-level languages, generally you're implementing the second way. Just have a length field, and then that tells you how long the string is, and that's pretty safe. But then most when you go down low level, like C, you actually see the former being used. So in this case, each string has a null terminator. Oh yeah, the XKCD Bobby tables. But with C, when you're looking at low level, it uses this end marker, and you have like each string has like a null terminator byte with the value 0. When you see like a 0 in the array of numbers, that means it's the end of the string. That's what it is. So here we have the string bad, and then the null terminator is just basically the number 0 at the end here. So we have 42 represents a B, 41 represents an A, and 44 represents a D, and then you have the 00. And these are all hex values, by the way. These are hex 42, hex 41, hex 44. And we've kind of mentioned a little bit about hex numbers in like 2 weeks ago or something. So now let's switch to what is a buffer in C. So a buffer is just a name that you call a fixed length of bytes. It's an array with a fixed length, fixed size. So you can use it to hold like a string up to the length of the buffer. Well, -1 because you need the null terminator. What happens if we attempt to store a string larger than our buffer? So should you throw an error? How do we know how to throw this error? What do we need to know? And obviously we would need to know how long this buffer is. But then if we don't know how long this buffer is, what if we don't know how long this buffer is and we just know where the beginning of the buffer resides? So then obviously in C, you just get in C, you normally just get a pointer to the beginning of a buffer, and then C is just like, have fun. We don't know how long it is. We're just going to start pushing stuff to that buffer. And sometimes you are lucky enough to find a function that actually requires you to give a length of the buffer, which makes it a little more secure. But I'm kind of getting ahead of myself. So if you ever heard of buffer overflow or any of that kind of stuff, you probably have heard of the function called gets. So this is like a man page of gets, and obviously the most important part of this man page just says never use this function. Why not? And then here I copied the bugs section of it. It says never use gets because it is impossible to tell without knowing how many characters gets is reading. So basically, this is the exact problem that we see here. Gets doesn't know how long this buffer that you have, so it just tries to put as long as the user input. So a brief explanation what gets does is it gets a line of text from the user, from standard input. The problem is the user can basically be malicious and just enter a string or an input string that is longer than whatever buffer you use to store it. And that is what happens when you get a buffer overflow. So here we have a very simple code here. The printf is asking what is your name, and then you have this gets this vulnerable gets function, and then you have this it prints out prints out what you wrote, and with %s tells in printf allows you to give like an argument and just basically replace the %s with input. So here we have our buffer is now defined locally along with some variable called x. And what I mean by locally, is defined as like a local function, a local variable inside a function. So where do you think local variables such as x and input are stored in memory? So obviously when you call a function, they should be different each time you call a function. So like when you do recursion, you want to be able to, you might have a variable x in the first call to recursion maybe equal to 1, but then the second time it equals to 2. So then you want to be able to differentiate between these two variables. So how do they solve it? They in C and basically every programming language, you have something what's called a stack, which allows you to push values to it and then store it temporarily and then call other functions and then store more variables on top of that stack. And then once you return or exit from a function, it will pop elements from that stack. So that's basically what is said here. And then you have this thing called a stack pointer, which tells you where you are on the stack, so the top of the stack. So in the case of C, in assembly, the stack pointer gets decremented when you push something and incremented when you pop something. That might seem a little bit inverse of what you would intuitively think, but that is how C works. Or just assembly. So here, because of how variables are put, X is actually, if you look at an address map, input would be located, X would be located after input. So let me pull this. I think I can just run this. It probably won't work. Okay. Oh yeah, I guess it does work. So we can see, oh, I forgot to explain the second part. You have this X, if X is changed. So you can see before X is 0. But then if X is not 0, it prints out you win. Otherwise, it prints out you fail. So obviously, let's say, if I were to just print out, let's say, run this. Let's see if I can just run it like that. Like that. So you can see here, if you just put out 4 characters, it won't do anything. It says you failed. If I decided to print out a lot of characters, well, let me run main first. And then you set, it will basically, what will happen is the A's will basically overwrite the variable X here. And it will become something else different. And it will say you win because the value of X has changed. So, explaining a buffer overflow. So you can see here, when I try to compile it, it will obviously, it will say that there's a, it will, I think there's a warning, and this warning here, it says it gets is decremented, deprecated, I mean, and then, if we look at here, buff, you can see here, I put 12 characters right here, and then put a D right here, and then it will say you win. So let's look at a more complex example. So, or like a little more complex. So now we want to also modify the value of X to be whatever this thing is. So not only do we want to just modify X, this code right here, you can just copy that. So now the question is, can you control what variables get set to what value? So remember, when you input each character, it's basically just another byte or another number byte in like a sequence of bytes. So you have 12 numbers right here basically, and then you start overflowing into int. So other variables such as this int one may take up more than 1 byte. In this case, the integer takes up 4 bytes of memory. And then what it will do is it will use this little endian byte order. So ints are 4 bytes, and we want to review what little endian is because you might not know what it is. So let's see. So if we're looking at little endian, basically, when we're looking at like a normal number system, we have the hundreds place. Let's see if I could draw something. I don't think I can. Okay, well, we don't need to. So we have the hundreds place, we have the tens place, we have the ones place. And then, if we think about it, basically the largest, most significant digit is put in the left to right format. But little endian is kind of like the opposite, where you have the ones place from on the far left, or with the lowest address value, and then the tens place, hundred place. But it's kind of like that, but not really. So let me kind of think I will explain it on the next one. So then we want to be able to input dead beef, make x equal to dead beef. So how would you do that? So here, the way that you do that is you can see here, this is 4 bytes right here. So we have A, B, 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 C, 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 and then we have each of these hex entities, these escape entities, represents 1 byte as well, 1 character, because this is an escaped /x. So you can see here /xef is 1 byte, /xbe is 1 character, and then so on and so forth. And if we look at this, what little endian means is instead of reading DE, AD, BE, EF for dead beef, it reads DE right here, AD right here, BE right here, and then EF. And that's kind of how little endian looks like. So now let's look at a little bit of buffer over getting code execution. So I know I'm going pretty fast. I think if you want to, you probably need to slow down a little more and kind of work with this if you are really wanting to learn this thing. But anyways, we want to get execution because modifying variables might be cool, but I mean, you can't really do much unless it's like, if this variable is that, then that might do something. But we want to actually get code execution and make it execute something that we want, anything arbitrary. So let's say I want to be able to make a virus out of some program or infect something, but I'm not condoning that. But let's say I want to do that. If I need to do that, I need to be able to get execution, be able to run anything I want on the binary, not just something that is in the binary itself. So yeah, we want to get code execution. So then we have this cool thing called a return value. If you recall, in a stack, in a stack we have this. Let's see. Wait, I think if you recall, the stack is basically push and pop whenever a function enters and exits. And when you return from a function, you want to know where to return to. Obviously, this function that you are in right now probably doesn't know who called it, because it could have been called from multiple different places. So what you need to do is have some kind of value to tell you where to jump to after the function exits. So what you do that is by having this return address, which tells the CPU, hey, after you're done with this function, jump to this other place. And that was who called you, the function that called you. And if you jump there, then you just return. So this return address is stored on the stack right below all the other local variables, which means it actually occurs after the buffer, because if you remember, the stack will decrement each time you push some value on the stack. So it's very interesting. So here, overriding the return address means we can basically jump anywhere, and potentially we can even execute our own code. And here's another YouTube video. I believe this is from Live Overflow's A Binary Exploitation. I also encourage you to watch all the other videos in his series. He does a lot of explanatory stuff, and with a lot of pictures. And he also, though he does talk a little fast, so I would encourage you to slow down his playing, and like maybe watch him multiple times. So now we're going to switch gears a little bit and look at print format, or format bugs. So I mentioned earlier a little bit about what printf, what it's doing. So when we're looking at C, how do we print numbers? So like in Java and Python, you have like a toString function or like a stir function, which lets you convert stuff into strings, which is pretty cool. But in C, you don't have that kind of stuff. So now you have printf. You have a format string, and then you have also a series of variable arguments. What that means is you can pass as many arguments as you want, as you need to printf. So like for example here, I have this printf, you have a hello world, %d and %s, these are placeholders for a number, d, which is decimal, and %s, which is a string. So you can see here the 1 is placed in here, and the C string, the string called C, with C, is placed in this particular slot. So why should this format string, this thing right here, why should this be like a string literal as opposed to maybe user input? So maybe the user might want to like do like want to do some format string, and maybe you just give them like ability to do that. So again, yeah, don't trust the user, because there's actually some interesting things in printf. So remember, printf allows you to pass any number of arguments, which is already kind of interesting. So %n is called the holy grail of printf. Well, not really, but that's very much case. So %n is actually a rather useless format specifier that lets the printf to write back an argument that you provided. So specifically, it lets you to count the number of characters that printf has written so far. So for example, if you have this, you have %d is 23, the second one is 155, %n, with this %n right here, you have written 6 characters. And then you pass a reference to a variable to write the number of characters written into that variable. So here, we can click on that. I think is literally just, yeah. So you can see here it prints out 23.155, and that's six characters. So it says the count is 6. So here is just basically, you can see %d, the count variable gets set to 6 afterwards. So now we look at format string bugs. So why is it bad? So this is why. So see if you can set the x variable to something else using the techniques mentioned. Well, kind of mentioned it, but see if you can get the x variable set. So you can see here, hello. So let's look at this program first. We have saying something, what is your name? And then it gives you an input. Lets you read in some input. This is actually secure. It's like because you pass the size of the buffer right here, so it's never going to exceed the buffer. So then this second line is printing of hello agent and then %d and x. And then you have this printf function right here, which you're passing in the input directly. So obviously we have this x is right now leet, but we want to be able to set it to dead. So what are some other format stuff we can try? So obviously, if we're looking at printf, man page is always very good start. And see if you can get shell. That's also kind of a little bit more tricky. Okay. Oh yeah, so here I did like an example already. So here, let me just break down what I did what is done here. So you can see first I compiled it, ran it. So here I just input a string Bob, and that's not doing much. Oh yeah, it's also printing out the value of x afterwards. Wait, oh, it's printing out the reference to x. So here you see first one is %n. You can see how x is now 0. I think I probably changed it up a bit from this code. I think I did. Yeah, I definitely did. So you have that printf right here. It's not in here. But basically, it'll print out the current value of x. So you can see here, the first one I did a %n, and you can see how x is immediately set to 0. So it looks like we actually, by setting %n, we can actually set x to 0. The variable x to 0. And then you can see here, if I pass in 4 characters with the %n, well, here I actually did change that to the first argument. Okay, I'll explain what this is. So you can see now x is 4 and 0. So what I did here, what that was different is, you can see that I did a $1 sign. This is actually a very interesting thing in printf to let you specify which argument you want to use. So $1 sign lets you use the first argument that you pass. The $2 sign would mean the second argument, and then so on and so forth. So here you can see 4 A's and x is now set to 4. So here I did a little. This is a little bit of the solution. So you can see here I basically just print out hex dead characters, and then I set that to n, back to n, and you can see now x is 57005, which is hex dead, and you killed it because x is dead. So yeah, so the there's also another thing that I added here, the bonus here, see, which is a exercise to the reader or the listener. See if you can be able to get shell. It's a little bit tricky, a little bit trickier, but it's doable. Well, I think this is another video. So, can I breeze through this really quickly? So there's some other topics that is definitely good to go over. And also, I would give a quick shout out to, there's actually a class now in UTD. If you're an undergrad and you're a senior, or maybe you're just a very good junior or whatever, there's actually a class called Cyber Advanced Attacks and Defense Lab or something. I do not remember the exact name, but it is taught by Dr. G, and he actually teaches all this kind of stuff. So he's actually teaching a class on binary exploitation. So if you're interested in this stuff, highly encourage you to take that class when he does teach it. And I think he teaches a malware analysis class, which does something similar to this in the fall for graduate students. But there are some more mitigations in this field of exploitation that makes your life a lot harder. So stack canary, Asler, 45 functions, all these things make it very hard, make your life much harder to pwn stuff. But there are actually other kind of counter mitigations that you can use to counter these. But basically, it's when you're looking at this exploitations, it has been and always will be like an arms race. You have the defense and different ways of defending your system versus ways of attacking the same system. But I mean, the best way to secure everything is just make your code secure and don't write bugs into your code. Easier said than done. But So of these mitigations, stack canaries, Aslar, and fortify functions, most of these are actually implemented mostly in used widely in the Linux systems. I think most distributions also compile programs by default that have all these enabled. And some additional resources for I would recommend, as I always preached very much now, Live Overflow is very very nice. I heard their the old .liveoverflow.com link domain has been broken for some time, but if you search up Live Overflow binary exploitation series or something, you should be able to find his play series on this on YouTube. Exploit education. I don't know if this link is correct or not, but exploit exercises. But I think let me double check actually. Yeah, is this one. So here, if you look at, I believe Nebula or Fusion actually. Wait, let's see if it's this one. I don't think. No, it's Phoenix. I mean, so Phoenix has a lot of exercises on basic stack, format, and heap exploitations. And these are some other stuff, network and some final challenges. But these are generally have the same kind of stack kind of challenges. And it takes you step by step all the way to the harder ones. And then these are some of the format bugs, and then you have heap, which I did not cover, but it's also pretty cool. Rob Emporium. This is a website if you want to learn a little bit, practice for Rob doing return oriented programming, which is also a technique, one of the counter mitigation techniques that you can use to kind of do binary exploitation. There's a course. It's in May 2015 by RPI Sec. They also have a lot of nice resources there. Honorable KR, I say it's on the medium side, but I think it's also a very cool website for working just general pwning and binary exploitation. And this one helped me a lot when I'm looking at learning about heap stuff. But this one's more when you start learning about heap. But I think that is the last slide. But yeah, that is a basic introduction to pwning. If there are any questions at this point, I can answer them. But yeah, that is it for today. If you have any questions you want to just ask in the stream chat in Discord, I can just answer them. But otherwise, I will probably just end here. It looks like we have a little less people today. I assume it's probably exams. But yeah, I think that's about it. Thanks everyone for coming. And I will go stop recording. Why won't this stop?
Thank you.
I think